Hello, everyone. My name is Ronak Chadha, and I am zooming in from the San Francisco Bay Area. My research project is titled Identifying Salient Language Features to Detect Pediatric Specific Language Impairment. My mentor is Dr. Peter Washington from the University of Hawaii at Manoa. Let's start off with a brief introduction. I chose this research topic because I was diagnosed with speech delays at a young age. Due to early intervention and detection, and with the help of a speech therapist, I was able to overcome this impairment. However, many others are not as lucky as me. Additionally, I'm also passionate about computer science and wanted to research and machine learning can be used to detect patterns in speech of children with specific language impairment, or SLI for short, to provide an easier and more accessible method of detecting this impairment early. So you may be asking, what is SLI? Well, SLI is a pediatric language disorder that delays development of typical speech functions in an estimated 7.4% of 5-year-olds, and is not caused by any known neurological, sensory, or intellectual disorders. Diagnosing and treating SLI early is important because it affects the development of vocabulary, grammar, and language skills, impacting written and verbal communication and hindering the ability to clearly communicate. SLI is difficult to detect given the lack of apparent symptoms. However, early detection is critical for improving outcomes. So, what are some of the currently available diagnostic methods and what are the drawbacks of them? Well, the current methods of diagnosis require trained speech language pathologists to evaluate the child using existing diagnostic tools, including direct observation, interviews and questionnaires completed by parents, guardians, or teachers, assessments of the child's learning ability, and standardized language tests. These methods are time consuming, expensive, and not easily accessible, as they're not always covered by insurance. The burden to detect speech impairment falls on parents and teachers who may be unable to notice the signs immediately, leading to learning disabilities and difficulties assimilating socially. Now, this leads into my research question. Can machine learning models be used to identify the salient features and speech patterns that can help detect and diagnose SLI earlier and more easily? So, here's how I approach the problem. My primary objective was to develop a machine learning solution to classify specific language impairment based on audio and language features. To build a machine learning model, I first needed to identify a dataset I could use to train the model. I selected the TalkBank collection of the Child ES dataset, which consists of various subsets of narrative based tasks and involves children attempting to accomplish a wordless picture task. The other reason for selecting this dataset was that previous research had indicated its superiority for specific language impairment detection over other available options. Next, I selected the gradient boosting classifier to train the data. This model works to achieve peak performance by optimizing the model's weights to reduce prediction errors. After training the dataset, I applied the built-in methods for feature selection to identify the salient features for a specific language impairment classification. For this, I used two different ML models to select the top features, and these included the gradient boosting classifier and logistic regression. Additionally, I used the mutual information quantity. I further trained the gradient boosting classifier on the top 15 features from each of these three sources. And the top 15 features from the three sources were then evaluated for their efficacy in predicting SLI. To do the evaluation, I performed cross-validation and split the data into 5 folds to calculate the average accuracy, precision, recall, and error, which helped identify the success of the top-ranked features, and that can inform the development of future digital diagnostics and therapeutics for a specific language impairment. Once the modeling was complete, the results showed that among the 3 machine learning models used, which were again gradient boosting classifier, the logistic regression, and mutual information quantities, the three common features ranked on the top 15 were word errors, repetitions, and possessives as possible indicators of SLI. These findings highlight two common methods of evaluating speech. The first is word errors, which refers to the number of wrong words used during a task. And the second is the number of words that are repeated during a task, otherwise known as repetitions. The research also found one uncommon method of evaluating speech, which is the number of possessives spoken during a task, and this can be further evaluated to study its correlation to the presence of specific language impairment. This slide shows the top 15 features ranked in importance from most to least important for each of the three methods, starting from the left with the top features for the gradient boosting classifier, followed by the logistic regression model in the middle, and the mutual information quantity on the very right. The top 15 features selected by the gradient boosting classifier were the best performing in predicting SLI with an average accuracy of 85%, average precision of 85%, and average recall of 83%, as illustrated in the charts below. The model trained with the top 15 features of the logistic regression method scored around 78% for all three of these metrics. Similarly, the top 15 features from the mutual information quantity scored around 78% for all three of these metrics. In conclusion, the top three features identified across the models are statistically significant and can be evaluated further for applicability to digital diagnosis and therapeutics for a specific language impairment. The deviation from the sample z-score of the typically developing group's mean word errors appears to be a strong indicator of the presence of specific language impairment. Also, the typically developing group tends to display lower repetitions of words during narrative-based tasks compared to the group with specific language impairment. As to the limitations of this research, the data used was limited to narrative-based speaking tasks in the TalkBank dataset and did not include any other type of speaking task. So the future work for improving the model for digital diagnosis and therapeutics for specific language impairment can include evaluation of the correlation between possessive spoken and specific language impairment, which was a new finding in this research. Future models should also incorporate a wide variety of speaking tasks in the training dataset. Lastly, deep neural network training can be conducted to let the model figure out which features are the most important from raw audio, video, or text inputs. I would like to wrap up with a special thanks to my mentor, Dr. Washington, for his guidance during this research project. This machine learning model shows a lot of promise for detecting specific language impairment more easily and helps to make these diagnostics more accessible. Thank you all so much for listening.